Good day, viewers. You are welcome. How to solve these nice algebraic equations? We have from the questions square root of k plus square root of minus k equals 12. I want to find the value of k. So here I'm going to be presenting two different methods to solve this. So let's say method 1. So from here we have square root of k plus the square root of, so this minus k, if I write it as minus 1 multiplied by k, so this equals 12. Then we can separate this as, if this is square root of k plus, by separating this we have square root of minus 1 multiplied by square root of k equals 12. Then so if you have square root of minus 1, so this equals I. Then we change this one to I, as we have square root of k plus I square root of k equals 12. Then so we have k here, and here is also square root of k. When we factor out square root of k from here, so in the bracket we have square root of k divided by square root of k. So this gives us 1 plus, and also square root of k divided by square root of k, so that is I, equals 12. So we need k. Let's divide both sides by 1 plus I. So by dividing both sides by 1 plus I, so we know this and this cancelled. So after that has been cancelled, so they have square root of k equals 12 divided by 1 plus I. So let's try and rationalize this. So if this is square root of k equals, we have to rationalize this as 12 divided by 1 plus I multiplied by 1 minus I divided by 1 minus I. So then we multiply above together. So we have square root of k equals 12 multiplied by 1 minus I. So this is bracket. And also we have 1 plus I multiplied by 1 minus I. So we have square root of k equals, so when we expand this out, we have 12 into bracket of 1 minus I divided by, so this is difference of 2 squared. So we multiply 1 by 1, that is 1 minus I multiplied by I, that is I squared. And anytime we have I squared, that equals minus 1. So therefore we have square root of k equals 12 into bracket of 1 minus I divided by I squared, that is minus 1. So minus times minus, that is plus, and 1 plus 1, that is 2. So we have 2 cancel 2 here, that is 6. So here we have square root of k equals 6 into bracket of 1 minus I. So having this, we have to take the square of both sides. So to cancel this root, so here is square root of k squared equals 6 into bracket of 1 minus I, then all squared. So square and square root cancelled, and we have the value of k equals, so we have k equals, so 6 bracket 1 minus I all squared, so it means 6 will take squared, and also 1 minus I will also take squared. So here we have k equals, so 6 squared, that is 36 into bracket of, so we have to expand this out as 1 minus I, then multiply by 1 minus I. So after having this, we have k equals 36 into bracket of, when we expand the whole of this out, we have 1 minus 2I plus I squared. So here we have k equals 36 into bracket of I squared, that is minus 1. So this and this cancelled each other. So we have minus 2I. So after having this, we have k equals, so multiply this together, we have minus 72I. So the value of k here that satisfies this problem is minus 72I. So it's an imaginary root, so which means we get a complex root. And for the second method, so let's consider this as method 2. So from the given problem, we have square root of k plus square root of minus k equals 12. So here, let's square both sides. So by squaring both sides, we have square root of k plus square root of minus k all squared equals 12 squared. So this expression is, we have a plus b squared, it means a squared plus b squared plus 2ab. That is, we have square root of k squared plus the square root of minus k squared plus 2 square root of k square root of minus k equals 12 squared. And then we have this cancelled and this also cancelled. So here is k plus minus k, so that becomes minus k plus 2 square root of k square root of minus k equals 12 times 12. So k cancelled k. Then here we have 2 square root of, so here is minus k, so that becomes minus k squared. So this equals 12 times 12. So let's divide both sides by 2 from here. So by dividing both sides by 2, 2 cancel 2. So and here we have minus k squared equals, so here is 2 here 1 and the 2 here, that is 6. So 6 times 12, we have it as 72. So then after having this, we have here as the square root of minus k squared, so this equals 72. So we can separate this as the square root of minus 1 multiplied by k squared equals 72. And by separating this, so here becomes square root of minus 1 multiplied by square root of k squared equals 72. So square and square root cancelled, and square root of minus 1, that is I. So we have I multiplied by k equals 72. So by dividing both sides by I from here, so we are going to have our k equals 72 divided by I. And 72 divided by I from here, so it's still the same thing as minus 72I. So when we rationalize, so get the same result when we apply the first method and the second method. So this is how to solve this. Thanks for watching, and don't forget to subscribe to this channel. See you in the next class. Never stop learning. Bye bye.